Tonight, we are going to explore a machine that NASA is building at this very moment, in quiet workshops and laboratories scattered across the country. A spaceship unlike any that has ever left the Earth. At its tip, it will carry a small nuclear reactor, a careful, controlled splitting of atoms that will glow steadily in the freezing dark between the worlds, where there is no air at all and no ordinary flame could ever live. And it is meant to do something we have never once managed in all of human history, to haul the heaviest load we have ever aimed at another planet, all the way across the vast cold gulf to Mars. While burning almost no fuel along the way, NASA calls the larger idea a railroad through space, a steady, patient line of freight running out toward the red planet and back again. And the way they intend to build it, and the strange small cargo it will carry down through the Martian sky, is far more clever and more surprising than you might imagine. How do you light a fire to cross between planets, when space itself holds no air for anything to burn? How can a reactor smaller than the spare generator sitting in someone's garage gather enough power to push a whole spaceship from one world to another? And why, after dreaming this very dream more than 50 years ago, and building it, and testing it out in the desert, and then quietly walking away from it, is the agency suddenly racing to finish it now, in time for a launch only a couple of short years away, until you finally understand why they call it a railroad to Mars? If you find a quiet comfort in drifting off to the strange wonders of distant worlds and the machines we send out to reach them, you might gently tap the like button or follow along, so that more curious and sleepy minds can find their way to stories like this one. There is nowhere you need to be right now and nothing you need to solve. So settle in. Find whatever position feels easiest, let your shoulders drop, and let us begin. To understand why this strange new ship matters, we have to begin with Mars itself, and with how very far away it really is. Mars is the fourth planet from the Sun, the next one out past our own. The small rusty world we have all seen as a reddish point of light in the evening sky. For as long as there have been people to look up, Mars has hung there, wandering slowly among the stars, glowing the dull, warm color of dried blood, which is why so many ancient peoples named it after their gods of war. It is a smaller world than ours, only about half as wide across. A cold desert planet wrapped in a thin whisper of air, with great dead volcanoes and dry canyons and rusty dust blowing in slow pink storms. And for the whole of human history, until almost yesterday, it was utterly beyond our reach, a place we could only dream about and never touch. For thousands of years, Mars was a mystery wrapped in that small red glow, and people filled the mystery with stories. They imagined it as a world much like our own, perhaps with seas and cities and beings who looked up at their own night sky and wondered about us in return. Just over 100 years ago, some astronomers, peering through their telescopes at the blurry red disk, became convinced they could see long straight lines crossing its face, and they decided these must be great canals, dug by a dying Martian civilization to carry water from the frozen poles to their thirsty cities. It was a beautiful idea, and it captured the imagination of the whole world, and it was completely wrong. There were no canals. There were no cities. The lines were a trick of tired eyes, straining at the edge of what they could see. But the dream of Mars as a living, reachable place had taken root, and it never quite let go of us. And then slowly, over the last several decades, we sent our machines, and we learned what Mars truly is. It is a cold, dry, beautiful, and lonely place. Its air is so thin that it is barely there at all, less than 1/100th as thick as the air you are breathing right now. And what little there is mostly carbon dioxide, a gas we could not breathe. Its surface is a frozen desert, with an average temperature far below the coldest winter night you have ever known, often around -80 degrees Fahrenheit, and far colder still near its icy poles. And yet it is a world of wonders. It holds the tallest volcano in the entire solar system, a mountain so vast that if you stood at its base, you could not even see its peak, for it would rise far beyond the curve of the horizon. It holds a canyon system so long and so deep that it would stretch clear across the whole of the United States and swallow the Grand Canyon as a single small side branch. Great slow dust storms sometimes rise and spread until they cloak the entire planet in a haze of pink. It is, in short, a real place, with a real and dramatic landscape, waiting quietly across the dark. And the dream of going there, of standing upon it, has only grown stronger the more we have come to know it. It is closer to us than almost any other world, and yet the distance is still hard to hold in the mind. Mars and Earth both circle the Sun, each on its own great loop, like two runners on two different tracks, one inside the other. Because the inner runner moves faster, the two planets are forever drifting nearer and then farther apart as they go around. At their closest, when both happen to be on the same side of the Sun, Mars comes within about 35 million miles of us. At their farthest, when the Sun sits between them, they can be separated by more than 200 million miles. On average, the gap between the two worlds runs to something like 140 million miles of empty space. Numbers that large slide right past the mind. So let us shrink them down. If the Earth were a marble sitting on a table in front of you, Mars at its closest would be another marble more than a mile away, with nothing at all in between but darkness. And here's the part that shapes everything about how we go there. Because the two planets are always moving, you cannot simply fly to Mars whenever you feel like it. You have to wait for the right moment, when the two worlds are lining up just so, when Mars will be in the right place by the time your ship arrives. That alignment, that open door, comes around only about once every 2 years. Miss it, and you must wait another 2 years for the next one. Everything we have ever sent to Mars, every lander, every rover, every orbiter, has had to leave during one of these narrow windows, launched at exactly the right instant so that ship and planet would meet far out in the dark many months later. It is a little like trying to throw a ball to a friend who is walking, so that you have to aim not at where they are, but at where they will be. Only here the friend is a whole planet, tens of millions of miles away, and the throw takes most of a year. So that is how we reach Mars today. We wait for the door to open. We light an enormous rocket and burn through a staggering amount of fuel just to fling our small spacecraft away from the Earth and out onto a long, curving path. And then, having spent nearly all that fuel in the first few minutes, the ship simply coasts, falling silently through space for months and months, until at last it crosses paths with Mars. If everything has gone perfectly, and so very much can go wrong, the ship drops a capsule into the thin Martian air and slows itself and sets down gently, and we end up with a robot rover about the size of a small car, rolling carefully across the red dust. And that, when it works, is one of the most wondrous things our species has ever done. To place a working machine on the surface of another planet, and to drive it by remote across all those millions of miles, is a kind of quiet miracle that we have almost let ourselves take for granted. And the landing itself is the hardest and most frightening part of all. A passage so perilous that the engineers who plan it have a grim and famous name for it. They call it the 7 minutes of terror. Here is why. When a spacecraft finally reaches Mars, after all those months, it is moving terribly fast, and it must somehow shed almost all of that speed in just a few minutes, slamming into the thin air, blazing behind a heat shield, throwing out parachutes, firing rockets to slow itself, and setting down softly, all in the space of a handful of breaths. And the cruelest part is this: Mars is so far away that a radio signal, even at the speed of light, takes many minutes to cross the gulf between us. So by the time the people back on Earth hear that their spacecraft has begun its descent, the truth is that it has already landed, or already crashed, several minutes earlier. There is nothing anyone can do but wait, helpless, while the little machine, all alone, faces its terror by itself, following instructions written long before, with no one able to help it or guide it through. Those 7 minutes are among the most agonizing in all of space exploration. A span of silence in which a mission that took years to build either lives or dies, far away, untouchable, on its own. Every successful Mars landing is a small victory wrung from that terror. But there is a deep and stubborn problem hiding inside this way of doing things, and the problem is fuel. We have, in truth, already begun to bump up against the very upper limit of how much we can send to Mars at all. And the thing standing in the way, the great wall we keep running into, is the simple, heavy, unforgiving matter of rocket fuel. To understand why, you have to understand a cruel little riddle that sits at the heart of all space travel. A riddle that engineers sometimes call the tyranny of the rocket equation. And once you see it, you can never quite unsee it. Unsee. It goes like this. A rocket flies by throwing fuel out the back, very fast, in the form of hot exhaust. The more fuel it throws, the faster it can go and the more it can carry. So, you might think, simply add more fuel. But here is the cruel twist. Fuel has weight, And every extra pound of fuel you add to the ship is another pound that the rest of the fuel now has to lift and carry and accelerate. So you add more fuel to carry the fuel, and that new fuel needs still more fuel to carry it. And the whole thing spirals upward, growing and growing, until the rocket becomes a vast tower that is almost entirely fuel, with only the tiniest sliver at the very top set aside for the actual ship and its precious cargo. It is a bit like trying to pack for a very long road trip with no gas stations along the way. You have to bring all your gas with you, but the gas is heavy, so you need a bigger truck. But the bigger truck burns more gas, so you need even more gas. So you need an even bigger truck. At some point, the whole idea collapses under its own weight. That is the wall we keep hitting on the road to Mars. We have made our rockets about as large as we know how to make them, and still, the fuel eats nearly everything, leaving only crumbs for the cargo. Even when you look at the very best plan anyone has dreamed up, the problem does not go away. It only grows clearer. The most ambitious vision for carrying great loads to Mars belongs to the enormous new spaceship called Starship, built to ride atop the largest and most powerful rocket booster ever made. A tower of fire taller than almost any building, just to heave itself up off the ground and into a low loop around the Earth. And once it is up there, it cannot simply turn and head for Mars, because it has already spent nearly all its fuel just getting off the ground. So before it can go anywhere at all, a whole fleet of more launches must follow, perhaps 10 more of those same giant boosters, each one hauling up a load of fuel to pour into the waiting ship, filling its empty tanks, drop by drop, launch by launch, until at last it is full again and ready to leave. Only then, after all of that, can it finally turn its nose toward the red planet. And the reward, when it works, is grand. A single fully loaded ship might deliver to Mars the equivalent of about 25 rovers, each the size of a small car. That truly would be a marvel. But think of the cost of it. A small mountain of rockets, an ocean of fuel, an enormous and delicate dance of launch after launch. And even then, it can all still only happen once every 2 years, when the door swings open. And now think of what it would really take, not just to visit Mars, but to stay. To build something there, to keep people alive on a frozen world with no air and no shelter and nothing to eat. You would need to send habitats and power plants and machines to make air and water and fuel and food and tools and spare parts and more food and far more besides, an entire small world's worth of supplies hauled across that vast gulf. The mass you would have to move is almost beyond imagining. And if every pound of it has to ride atop a tower that is mostly fuel, launched only once every 2 years, then the dream of truly living on Mars begins to feel impossibly heavy, crushed beneath the weight of its own fuel before it ever leaves the ground. There simply has to be a better way to do this. And there is a better way. And it is exactly why NASA is now building the machine at the center of tonight's story. It is called Space Reactor One. And if all goes to plan, it will become the first spaceship in history to carry its own nuclear reactor between the planets, powered not by burning fuel, but by the patient splitting of atoms, It is one of the central pillars of a bold new direction for the agency under its new leadership. A turn back toward an old and powerful idea that had been set aside for half a century. And the most thrilling thing about it, the thing that makes engineers lean forward in their chairs, is that this is not some distant dream meant for our grandchildren. The plan is to build the thing now, in the year 2026, and to launch it when the next door to Mars swings open, in the year 2028. That is breathtakingly soon. It sounds almost impossible, and to understand how it could be possible, and why a nuclear ship changes everything, we first have to understand what a nuclear spaceship even is, because that phrase can mean more than one thing. So let us go gently into the idea, one careful step at a time, because there is nothing here that needs to feel complicated. At the heart of it all is something called nuclear fission, and the word fission simply means splitting. Deep inside certain heavy atoms, in elements like uranium, there is an enormous amount of energy locked away, bound up in the very core of the atom. When you carefully split one of those heavy atoms apart, that locked away energy comes pouring out, mostly in the form of heat, an astonishing amount of heat from an astonishingly tiny speck of material. This is not new or exotic science. It is the very same process that has quietly run the nuclear power plants here on Earth since the 1950s. The plants that have lit cities and warmed homes for generations. A reactor is simply a place where we let those atoms split in a slow, steady, controlled way, gathering the heat as it comes, never letting it run away from us. The whole trick of nuclear power, on Earth or in space, is patience and control, coaxing the energy out gently rather than all at once. It helps to picture, for just a moment, what is really happening down there, smaller than the eye could ever see. Everything around you, the blanket over you, the air in the room, your own hand, is made of tiny pieces called atoms, almost unimaginably small, far too small to see. And at the center of each atom sits an even tinier core, holding within it a tremendous amount of energy, bound up tight, the way a coiled spring holds the force you pressed into it. For most of the matter in the world, that energy stays locked away forever, quiet and harmless. But in a few special, heavy kinds of atoms, the core is just barely held together, almost ready to come apart. And if you nudge one of those atoms in just the right way, it splits in two. And as it splits, a whisper of its matter simply vanishes, turned directly into a burst of pure energy. It was one of the great discoveries of the last century, that a tiny amount of matter can become an enormous amount of energy, that the two are really one and the same. The splitting of a single atom releases only a little, but there are uncountable trillions of atoms in even a small piece of fuel. And when one splitting atom nudges its neighbors into splitting too, and they nudge theirs, the process can build into a steady, self-sustaining glow of heat, atom after atom giving up its hidden store. The art of a reactor is simply to let this happen slowly and steadily, never too fast, always in hand, drawing off the warmth in a calm and even stream, like banking a fire so it burns low and long through the night rather than flaring up and dying. Controlled, patient, steady. That gentle steadiness is the whole secret. Now, when it comes to using that heat to actually move a spaceship through space, there are two main paths an engineer can choose between, and they each have their own quiet beauty. Let us look at the first one, because it is the easier of the two to picture, and it sits closest to the rockets we already know. The first path is called nuclear thermal. In many ways it works much like an ordinary rocket engine, only with the reactor standing in for the fire. In a normal rocket, you burn fuel to make a great rush of hot gas, and that gas blasts out the back of the engine through a narrow opening called a nozzle. And the force of all that gas rushing out one way shoves the rocket the other way. That is what thrust is. The simple push of throwing something backward very hard. In a nuclear thermal engine, there is no burning at all. Instead, you choose a fuel that is wonderfully light. The very lightest thing there is. A gas called hydrogen. The simplest and most plentiful substance in the entire universe. You chill that hydrogen down to a temperature so cold it is hard to imagine. Far colder than any winter, around minus 423 degrees Fahrenheit. Cold enough that the gas turns into a liquid, dense and easy to carry, and then you pump that frigid liquid hydrogen straight into the blazing hot reactor. Picture that moment for a second, because it is rather lovely in its violence. The super cold liquid, colder than almost anything in nature, meets the searing heat of the splitting atoms. And the hydrogen reacts the way you might expect. It flashes instantly from a frozen liquid into a furiously expanding gas, swelling, racing, desperate to escape. It rushes out through the nozzle in a great roaring stream, and that stream of escaping gas pushes the ship forward, just like any rocket. The difference is all in the efficiency. A normal rocket has to burn its fuel, and burning needs oxygen. And there is no oxygen out in space. So an ordinary rocket has to lug along its own heavy supply of oxygen everywhere it goes. A great dead weight that crowds out the cargo. A nuclear thermal engine needs no oxygen at all, because it is not burning anything, it is only heating. And so it turns out to be about 5 times more efficient than the rockets we use today. 5 times. Which means you only need to carry about 1/5 as much fuel to do the same job. And once you have saved all that weight, you have a wonderful choice to make. You could travel 5 times faster, or reach 5 times farther, or carry 5 times more cargo, or mix those gifts together in any way you like. When you hear people speak of flying to Mars in only 45 days, instead of most of a year, this is the kind of engine they are dreaming of. It is a marvelous idea. And speed, for human travelers, is not just about saving time. It is about safety. The long open road between the planets is bathed in a constant rain of invisible radiation, streaming in from the sun and from the distant stars. And the longer a crew spends out in that rain, the more of it their bodies must absorb. A journey that takes most of a year exposes the travelers far more than a journey of only a few weeks. So a faster ship is a kinder ship, one that carries its people quickly through the danger and delivers them sooner to the shelter of another world. That is part of why the dream of the 45-day crossing burns so brightly in the minds of those who imagine sending people, not just cargo, to Mars. To go faster is to keep the travelers safer. It is a marvelous idea, and one day it may well carry the first cruise. But here's the thing, as marvelous as that is, it is not the path NASA has chosen for this first ship. Because 5 times better is wonderful, but there is a way to do something closer to 10 times better, and to reach for that. We turn to the second path, the one called nuclear electric, which is a little stranger, a little more patient, and in its own quiet way, far more powerful for the long road to Mars. In a nuclear electric ship, the reactor does not heat any fuel at all. Instead, the reactor has just one job. It makes electricity. All that heat from the splitting atoms gets gathered up and turned into a steady river of electric power, the same kind of power that runs through the walls of your home. And that electricity is then fed to a very special and rather beautiful kind of engine called an ion thruster. The name sounds like something out of a science fiction film, some far future invention. But in truth, ion thrusters are old friends. We have been quietly using them for decades to nudge satellites into place and to push small probes out into the deep dark of the solar system. Every one of those little internet satellites circling overhead right now, the great swarms of them, uses a tiny ion thruster to hold its position and steer. They are everywhere above us. We simply never see them work. And ion thrusters have already carried us to remarkable places, quietly, without much fanfare. More than 25 years ago, a small probe became the first ship ever to fly through deep space, driven mainly by an ion engine, proving the gentle idea could work far from home. Years later, another spacecraft used ion engines to do something no ship had ever done, to travel out into the belt of rocky worlds between Mars and the giant planets, to slip into orbit around one great asteroid, study it patiently, and then gently lift away and fly on to orbit a second one, all on the strength of that soft and tireless push. No rocket-burning fuel could have managed such a thing, weaving from world to world. Only the patient ion drive, sipping its power, nudging ever onward, could do it. And when one of these engines runs, it gives off the faintest, loveliest glow, a soft and ghostly blue light streaming silently from its back. The gentlest possible sign of the force it is quietly making. There is no roar, no fire, no thunder, only that pale blue whisper in the dark, and a ship that is ever so slightly, always speeding up. The way an ion thruster pushes a ship is gentle and almost otherworldly. So let us walk through it slowly. You begin with a small amount of gas, often a heavy gas called xenon, held inside the engine. Into that gas you pour electricity, and as the electricity flows in, it begins to stir the atoms of the gas, exciting them, energizing them, charging them up, making them restless and quick. The more electricity you feed in, the more agitated and energetic those tiny atoms become, jostling and racing about. And then, once they are charged just so, you use a magnetic field to grab hold of them and fling them out the back of the engine, hurling them away into space at tremendous speed. There is no flame here, no explosion, no burning, no turning of liquid into gas. There is only this, energy delivered straight to the atoms, and the motion of those flung atoms turning, ever so slightly, into the motion of the whole ship. It is one of the most efficient ways to move through space that we have ever found, getting close to 10 times the efficiency of an ordinary rocket. There is, of course, a trade, because there is always a trade. The ion thruster is not throwing fire and thunder out the back. It is flinging a thin, faint stream of atoms, and the push it gives is astonishingly gentle. We are not talking about the violent shove of a launch rocket that pins you to your seat. We are talking about a push so soft that here on Earth it could barely stir a feather. If you held an ion thruster in your hand, you would feel only the lightest breath. So it cannot blast off a launch pad, and it cannot hurry. What it can do is push and never stop pushing. Day after day, week after week, month after month, that feather-light force keeps adding speed, a tiny bit at a time, without rest, without pause. And here is the wonder of it. A small push that never stops will, given enough time, carry you faster and farther than a single great shove ever could. It is the steady patience of it that wins in the end. You give up the quick burst of speed at the start, and in exchange, you gain an enormous top speed over the long, quiet haul. And for the great distances of deep space, where there is nothing but time, that is exactly the bargain you want to make. The tortoise, out there in the dark, truly does beat the hare. This, then, is the choice NASA has made for Space Reactor One: nuclear electric power, driving gentle ion thrusters, pushing patiently across the Gulf to Mars. And the reason behind that choice was laid out plainly in a presentation given in the spring of 2026, in a single phrase that has stuck to the project ever since. NASA, they said, is building a railroad to Mars. Not a railroad of iron rails and wooden ties, of course. Not a literal train track laid across the void. They meant it as a picture, a way of seeing the thing. Because what nuclear electric propulsion does is move cargo through space the same way the great freight trains move goods across a continent here on Earth. Not quickly, not in a hurry, but with enormous, tireless, unstoppable efficiency. Hauling great heavy loads over vast distances for almost nothing, slow and steady and dependable. A freight train does not race. It simply arrives, again and again, carrying more than anything else can carry. And that is what this ship is meant to be. The first freight train running out along an invisible railroad to another world. It is a fitting picture, the railroad, in more ways than one. Think back to how the great railroads changed our own world before them. To cross a continent was a desperate, dangerous, months-long ordeal, attempted only by the boldest, with most of what you owned left behind for lack of room. And then the rails were laid, slowly, mile by mile, across the empty land, and everything changed. Suddenly, a journey that had been a gamble with your life became something ordinary and dependable. Goods flowed, people followed, towns sprang up along the line. A wilderness became a place where ordinary lives could be built, simply because a steady, reliable, efficient way to cross it had been laid down. That is exactly the change a railroad to Mars would bring. Not the rare and heroic single crossing, attempted once in a generation, but a steady line, running and running, carrying load after load, turning an impossible frontier into a reachable place. The first train is always the slowest and the hardest. But once the line exists, everything that follows becomes possible. There is something deeply restful in imagining that crossing, the long, slow year of it. Once the ship has left the Earth behind and settled onto its path, there is no drama, no urgency, nothing sudden at all. Just the small, bright ship, falling through the immense dark, its reactor glowing softly at its tip, its thrusters whispering their faint blue breath. Hour after hour, day after day, adding the tiniest sliver of speed with every passing moment. The Earth shrinks slowly behind it until it is only a pale blue star among the others. The sun grows a little smaller, a little dimmer. Mars, ahead, is still only a reddish point of light, growing imperceptibly brighter across the months. Nothing needs to happen quickly. Nothing needs tending. The engineers back on Earth can only watch and wait and trust the long, quiet arc of the journey, the way you might watch a ship sail slowly out past the horizon, knowing it will be a long while yet before it reaches the far shore. There is a peace in that kind of patience, in a thing that simply continues, faithfully, without hurry, certain of where it is going, even though the going takes so very long. It is the opposite of everything frantic. It is the slow, sure, unworried motion of something that knows it will arrive. So this first ship, Space Reactor One, will not streak to Mars in 45 days the way a nuclear thermal rocket might. It will take its time, about a year, to make the crossing. But in exchange for that patience, it will become, by far, the largest vehicle we have ever sent toward the Red Planet. And it will get there, having sipped only the barest, most negligible trickle of fuel. That is the trade the railroad makes. Give up speed and gain the power to carry almost anything, almost for free. Now let us walk slowly up and down the length of this strange new ship, from its glowing tip to its waiting cargo, and look at how each piece does its quiet work, one part at a time, the way you might walk the length of a train and look into each car. The first part, right at the pointed front of the ship, is the heart of the whole thing, the nuclear fission reactor itself. And the most surprising thing about it is how small it is. When you picture a nuclear reactor, you might imagine one of those huge plants on the horizon, with great curving towers breathing steam into the sky. Those grid reactors that power our cities are giants, each one pouring out roughly 1 billion watts of power, enough to light a whole region. That would be wild. Wasteful overkill for a single spaceship. There are far smaller reactors too, the kind tucked inside a nuclear submarine, and those make something like 20 million watts, still far too much. But Space Reactor One goes smaller still, much smaller, all the way down to a power of only about 20,000 watts. 20,000 watts. To put that in something you can hold in your mind, that is about the same as a backup generator you might buy at a hardware store to keep the lights and the refrigerator running in your house during a storm. The first nuclear engine ever to cross between the planets will be in raw power, about the size of a household generator. And that smallness is not a flaw or a shortcoming. It is a careful, deliberate choice. NASA has decided to start small and modest, to prove first that the thing can be done at all. That a reactor can fly safely and steadily between worlds, before anyone tries to build the bigger, more powerful versions that will surely come later. It is the wisdom of taking the first step gently. Walk before you run. Prove the small thing first. You might wonder, as many gentle people do, whether it is safe to send a nuclear reactor up on a rocket at all. And it is a fair and caring thing to wonder. But the answer is reassuring, and it lets the worry rest. The reactor does not fly while it is running. When it is launched from the Earth, it is cold and quiet and inert, its fuel still locked away and harmless, no more dangerous than the metal it is made of. It is only switched on, only awakened into its glowing nuclear life. Once it is safely far out in space, well away from the Earth and everyone on it. So even in the rare event that something went wrong with the launch, there would be no nuclear danger raining down, because the reactor would not yet be a reactor at all, only a sleeping thing waiting to be woken in the safety of the void. The engineers have thought long and carefully about this, the way good and responsible people do, and they have built the whole plan around keeping the Earth and its people safe. The fire is only ever lit once it is far from home. The second part sits just behind the reactor, and it is there to keep everything else safe. It is a radiation shield, shaped like a cone, like a wide, blunt arrowhead pointing back along the ship. A reactor, as it splits its atoms, throws out not only heat but also radiation, invisible rays that could, over time, harm the delicate machinery further down the ship. So the shield stands like a great umbrella between the reactor and everything behind it, casting a long protected shadow down the length of the vessel. Everything important rides in that shadow, sheltered, kept safe from the quiet storm at the front. It is a simple idea, really. Put a wall between the dangerous thing and the precious things, and stand behind the wall. The third part, tucked just behind the shield, is where the magic of turning heat into power actually happens. It is called the power conversion unit. And it works by a clever and graceful method known as a heat pipe system. Let me walk you through its gentle circle, because it is the kind of thing that is almost soothing to follow. A liquid flows quietly through a pipe, up into the reactor, there. The fierce heat of the splitting atoms boils that liquid away into a vapor, a gas. The gas, swelling and rising, flows naturally onward through a loop in the pipe, and as it rushes along, it spins the blades of a turbine, like wind turning a windmill. That spinning turbine is joined to an electric generator, and so the motion becomes electricity. The very power the ship needs to feed its thrusters. And then, its work done. The gas drifts on a little farther, where it cools and slows, and gathers itself back together into a liquid once more. And that liquid flows quietly back down toward the reactor to begin the whole circle again. Around and around it goes. Heat to vapor to spinning to power to cooling to liquid and back to heat. A closed and endless loop, sealed off from everything outside. And because nothing escapes and nothing is used up but the slow, patient splitting of the fuel, this gentle cycle can run for years and years on end, with no one to tend it. No maintenance at all, turning quietly in the dark, until at last, far in the future, the nuclear fuel is finally spent. The fourth part is the simplest of all, and yet it matters. Below the power converter stretches a long, slender framework of metal beams, a truss, a kind of open scaffold. Its only purpose is to hold things apart. It puts a good long stretch of empty distance between the reactor at the front and the spacecraft's delicate brain and instruments further back, so that the radiation has even more room to fade and thin out before it can reach the computers that steer the ship. Distance itself is a kind of shield. The farther you stand from the fire, the gentler its heat. And so this long, bony spine of metal simply keeps the dangerous front and the delicate back at a safe and respectful arm's length from one another. The fifth part spreads out from the ship like a pair of great wings, and at first glance you might mistake it for exactly that, wings to fly with. But space has no air, and there is nothing for a wing to push against, so these are not wings at all. They are radiators, great flat panels whose job is to throw away heat. It may seem strange that a ship would need to shed heat in the bitter cold of space, but a reactor, for all its usefulness, makes far more warmth than the ship can use, and that extra heat has to go somewhere, or it would slowly build and build until it cooked the vessel from within. So these broad, thin panels, made of a light and sturdy metal called titanium, fan out into the void, offering up as much surface as they can, and the unwanted heat radiates quietly off of them and out into the endless cold of space, glowing softly away into the dark. They are the ship's way of keeping its own cool, its great patient wings of cold, spreading heat out into the nothing. The sixth part, riding behind all of that, is the spacecraft itself, the body that holds the power and the propulsion, the part that takes the electricity and turns it into that gentle, endless ion push. And here is one of the most charming surprises in the whole story. This piece, in many ways the hardest of all to design and build, is already very nearly finished. And it is finished not because anyone rushed it, but because it was quietly being built all along for an entirely different purpose. And now it has simply found a new and better use. Years ago, as part of an earlier plan to return astronauts to the moon, NASA had begun building something called the Lunar Gateway, a small space station meant to circle the moon, a waypoint where crews could pause and switch from one ship to another on their way down to the surface. That gateway was designed to hold its place in lunar orbit using ion thrusters, the very same gentle engines we have been describing, only built to a much larger and more capable scale than the little ones on the satellites. The new leadership at NASA decided to set the old gateway plan aside. But they were careful, and they were wise, and they did not throw away the good work that had already been done. Instead, they took the pieces and gave them new lives. The living quarters that were meant for the gateway will become part of a base on the surface of the moon. And the great propulsion section, the powerful ion engine that was meant to hold a station in lunar orbit, was lifted out and reborn as the body of Space Reactor One, an engine already strong enough, with a little help, to carry itself and a small precious cargo all the way from the Earth to Mars. There is a quiet thrift in that, a kind of grace, the way a thing built for one dream is gently repurposed to carry another. Nothing wasted, nothing thrown away, only made new. And that brings us to the seventh and final part, the small but wonderful cargo that this whole great railroad has been built to deliver. It has a name, and the name is lovely. It is called Skyfall. And to understand Skyfall, we have to imagine the end of the long journey, the moment, about a year after launch, when Space Reactor One at last draws near to Mars after its slow, patient crossing of the dark. Let us go there now, gently, and watch what happens as the freight train pulls into the station at the edge of another world. After a year of quiet falling through the void, the ship arrives at Mars, and it releases a single small capsule, sending it down toward the thin Martian air while the great reactor ship sails onward. The capsule plunges into the wisp of atmosphere, and the first thing it meets is heat, the fierce friction of entry, and so it hides behind a heat shield, a curved barrier that takes the burning on its face while the precious thing inside stays cool and safe. Picture it for a moment, that small capsule racing down through the thin red air, wrapped in a glow of fire from the friction of its own speed, screaming toward the surface of a world a year's journey from home, with no one near to help it, following its instructions all alone, exactly as ingenuity once did, exactly as every brave Martian visitor has had to do. It uses that air, thin as it is, to brake, to slow, to bleed off its tremendous speed. Then, when it is slowed enough, it unfurls a parachute. a special kind that can open even while still moving faster than sound, blooming above the falling capsule and dragging it gently into a slower, softer descent. And then, drifting now, no longer racing, the capsule lets its heat shield fall away, and the cargo within is revealed at last. Not a rover, not a lander on legs. Something we have never sent to Mars in numbers before. 3 small helicopters. 3 little flying drones, waiting in the Martian sky. These 3 small flyers are not built from scratch, and that, again, is part of the cleverness of the whole plan. They are built on the very same design as a tiny helicopter named Ingenuity, which traveled to Mars in the year 2020 and made history as the first machine ever to fly under its own power through the air of another planet. That little craft was only meant to make a handful of test flights, a brief experiment, a proof that flight on Mars was even possible. And making it fly at all was a wonder, because flying on Mars is far harder than flying here. The air there is so terribly thin, barely 1/100th of what we have, that there is almost nothing for a wing or a blade to push against, to get any lift at all from such thin air. The little helicopter had to spin its blades many times faster than any helicopter ever flies on Earth, whirling them in a furious blur just to claw its way a few feet off the ground. No one knew for certain it would work until the morning it lifted off, rose gently into the pink Martian sky, hovered there for a few seconds in the thin, cold air, and set itself softly back down. The first machine in all of history to fly under its own power through the air of another planet. People back on Earth wept and cheered over those few seconds of hovering. Instead of stopping there, that brave little flyer went on to make 72 separate flights over nearly 3 years, far more than anyone had ever hoped, hopping and soaring across the red landscape long after it had proven its point, scouting ahead of its companion rover, a small, faithful thing that simply refused to quit, until, at last, the cold and the wear of that harsh world brought its flying days to a gentle end. So when NASA needed flyers for this new mission, they did not start over. They took that proven, beloved little design, the one that had already shown it could fly on Mars again and again, and they built 3 more of it. And that, more than anything, is what makes this whole bold plan possible in such a short span of time. There is no heavy lander to invent, no airbags to design, no elaborate crane to lower a rover gently to the ground, none of the dangerous and complicated machinery that every other Mars landing has needed. Instead, you simply build 3 more copies of a thing that already works, drop them gently into the Martian sky, and let them fly off to do their work. Simplicity itself becomes the secret. And the work these 3 little helicopters are sent to do is one of the most important and most human tasks we have ever asked a robot to perform. They are scouts. They are going ahead of us to find the place where the first people will one day land. Each of the 3 carries cameras that can see the ground in fine and patient detail, and a special kind of radar that can peer down beneath the surface, reading the hidden layers of rock and soil below. And they are looking for two things, two gifts that the future astronauts will need above all others. The first thing they are searching for is, very simply, a safe place to land. Somewhere flat, somewhere open, somewhere broad and smooth and free of the boulders and slopes and hidden dangers that could doom a much larger ship carrying living human beings. A rover the size of a car can pick its way carefully across rough ground, but a great ship bringing a human crew down from space needs a wide, clear, gentle place to set its feet. So the little helicopters will fly out across the red plains, looking down with their patient cameras, searching for that perfect, welcoming clearing, the spot where, someday, the first human footprints on Mars might begin. The second thing they are hunting for lies hidden underground, and it is the most precious substance on all of Mars. They are searching for water, frozen as ice beneath the surface. And water, out there, is worth more than gold, because water is life in more ways than one. The crew would need it to drink, of course, and to grow food, and simply to stay alive in that barren place. But water is also fuel. Split water apart and you get hydrogen and oxygen, the very stuff that rockets burn. So a buried reservoir of ice on Mars would mean that astronauts would not have to carry every drop of their return fuel all the way from Earth. They could make it there, on the spot, from the frozen water beneath their boots, and use it to light the fire that carries them home again. To find water ice on Mars is to find the thing that turns a one-way journey into a round trip. The thing that makes it possible not just to reach Mars, but to come back from it. And so the little helicopters fly, and look down, and look beneath, searching the cold red ground for the hidden ice that might one day bring people safely home. So that is Space Reactor One, the first freight train along the new railroad to Mars. But you will remember that the railroad is the larger idea, the bigger dream, and a single train is only the beginning of a railroad. This first mission is meant to prove that the line can be built and run at all, and NASA's plans do not stop there. They reach onward, gently, into the years that follow. Not long after the Mars mission, around the year 2030, comes the next step, a machine called Lunar Reactor One. This one is not meant to fly between planets. It is meant to sit on the surface of the moon and provide power, steady and reliable, to whatever base and machinery we place there. And it solves a quiet, brutal problem that the moon poses to anyone who tries to live on it. The lunar night on the moon. A single night does not last a handful of hours as it does here. It lasts about 14 of our Earth days, 2 full weeks of unbroken darkness and bitter, deepening cold. During that long night, solar panels are useless because there is no sun to feed them, and unheated equipment can freeze solid and die. A small nuclear reactor changes everything because it does not care whether the sun is shining. It splits its atoms and makes its warmth and its power just the same. Through the brightest noon and the longest, coldest, darkest night, keeping the lights on and the machines alive straight through those 2 long weeks of black. A steady heart of warmth, glowing patiently through the lunar dark. There is a quiet beauty in imagining that. A small reactor sitting alone on the gray dust of the moon. The Earth hanging blue and lovely in its black sky, while the long lunar night settles over everything for 2 whole weeks, all around. The cold deepens toward depths that would kill any unprotected machine. The solar panels, useless now, sit, dark and still. But the little reactor does not falter. It does not even notice the darkness. It simply keeps splitting its atoms, one by one, making its faithful warmth and its steady power, keeping the lights glowing inside the base and the machines alive and the heaters running. Hour after hour, day after day, straight through the long black night, until at last the slow sun rises again over the lunar horizon. A small, dependable fire, holding back the dark and the cold, asking nothing, simply doing its quiet work. There is something in that image that feels almost like a companion, a faithful presence keeping watch while everything else sleeps. And from there, the dream grows larger still, the way these things do, step building upon step. The lessons learned from that first small reactor on the moon will feed into bigger and more powerful reactors all through the years that follow. Machines that make not thousands of watts, but millions of them. True workhorses of power. And those larger reactors are exactly what we would need for the greatest journey of all. The long human voyages to Mars that may come in the years ahead. Missions that would carry living crews across that vast gulf and keep them alive and warm and powered for years at a time. Far from home. Far from the sun, out in the deep and patient dark. It all begins, though, with this one small ship. This household generator wrapped in titanium wings. This gentle freight train setting out along an invisible railroad, carrying 3 little helicopters toward another world. There is a long human story folded into all of this too, and it is worth telling, because the dream of a nuclear rocket is not a new one. It is, in fact, an old dream, an old hope that was once chased hard and then abandoned, and is only now, after more than half a century, being taken up again. Let us go back, then, to a different time, to the 1960s, when the world was first reaching for space and everything still seemed possible. In those years, in the high desert of the American West, in a remote and dusty place far from any town, a group of engineers and scientists set out to do something audacious. They were going to build a nuclear rocket engine, the same basic idea we have been describing. The nuclear thermal engine, hydrogen heated by a reactor and flung out a nozzle, was being designed and built and actually tested right there in the desert, more than 50 years ago. They believed, and many of the great minds of that era believed with them, that the future of space travel would be nuclear, that the way humanity would one day reach Mars was on a pillar of atomic fire, one of the most famous of all the rocket pioneers, the man who had designed the giant rockets that would carry astronauts to the moon, dreamed openly of using nuclear rockets to send the first people onto Mars. It was not a fringe idea. It was, for a time, the mainstream vision of where we were going and how we would get there, out in that desert. They fired their nuclear engines and watched them roar, and the dream felt close enough to touch. It was an enormous effort, carried out by thousands of dedicated people over many years. They built test stands out in the empty desert, far from anyone, and bolted their nuclear engines down and ran them at full power, sending great plumes of superheated hydrogen screaming up into the dry desert sky. Engine after engine, year after year, they tested and refined and learned, pushing the machines harder each time, proving that a reactor really could heat a rocket, really could make thrust, really could one day carry people across the dark to another world. These were brilliant, hopeful people, working at the very edge of what was known, certain that they were building the engines that would take the next generation to Mars. They could picture it so clearly. They could almost see the ships rising on pillars of atomic fire, see the first footprints in the red dust, see a future that felt only a few short years away. They poured the best of themselves into that desert dream. And then, slowly, the dream was set down. The great race to the moon was won, and the urgency drained out of the space program. Budgets were cut. Priorities shifted. The country turned its attention to other things, to troubles closer to home. And one by one, the bold projects of that hopeful era were quietly shelved, the nuclear rocket among them. The engines that had roared in the desert were powered down. The plans were rolled up and filed away. The brilliant people who had given their working lives to the dream of an atomic path to Mars watched it fade. And many of them surely went to their graves believing it would never be revived. That they had built something wonderful and ahead of its time, only to see the world walk away from it. It is a particular kind of heartbreak, that to be right too early, to build the future and then watch it be forgotten. There is a quiet ache in it that anyone who has ever poured themselves into something only to set it aside will understand. But the wonderful thing about a good idea is that it does not really die. It only sleeps. It waits, patient as a buried seed, for the season to come around again. And now, after more than 50 years, the season has come around again. The materials are better now. The reactors can be made smaller and safer. The computers that steer a ship are vastly more capable than anything those desert engineers could have dreamed. We have even quietly tested small nuclear reactors meant for space in the years just past, proving once more that the thing can be done. And the old dream, the one that roared in the desert and was then laid down to sleep, has been gently woken and dusted off and taken up again by a new generation reaching for the same red planet their grandparents reached for. There is something deeply moving in that. If you let it settle into you, The work was not wasted after all. It was only early. The seed those people planted in the desert sand more than 50 years ago is finally, at last, beginning to grow. They were not wrong. They were simply ahead of their time, and the future they could see so clearly is, at long last, beginning to arrive. Now you might wonder, lying here in the quiet warmth, why any of this should matter to you, here on this gentle blue world, with Mars no more than a faraway reddish star. And it matters in more ways than you might first think, though none of it asks anything of you tonight. It matters first because of what it would mean to truly open the road to Mars. Right now, every trip to the red planet is a rare and precious thing, a once-in-2 years event, a desperate cramming of as much as possible into a single narrow window, with fuel eating nearly everything. But a railroad changes that. A railroad means regular, dependable, affordable passage. It means we could send heavy cargo ahead, again and again, building up supplies on Mars long before any people arrive, the way pioneers once sent provisions ahead along a trail. It means that reaching another planet could become not a single heroic gamble, but a steady, ordinary, reliable thing. The way a freight line, once laid, simply runs and runs, that is the quiet revolution hidden inside this small ship. Not speed, but steadiness. Not a single leap, but an open road. And think of what that steadiness would allow. With a railroad running, we would not have to gamble everything on a single perfect mission. We could send supplies ahead, again and again, year after year, quietly stockpiling everything a future crew might need, long before any human being set out. Shelters could be waiting. Power could be waiting. Stores of food and air and fuel could be waiting, built up patiently over many quiet cargo runs, so that when the first people finally arrived, they would not be arriving at an empty and hostile desert, but at a place already partly prepared for them, with the hardest and heaviest things already there. It is exactly how the great expeditions of our own history were made survivable, by sending provisions ahead, by laying in stores along the route, by never asking a single journey to carry the whole impossible weight all at once. A railroad to Mars would let us be patient and careful and safe, building up the means of survival slowly and surely before ever risking a human life. That patience, that quiet preparation, is the gift the freight train brings. It matters, too, because of the larger door it would open, far beyond Mars alone. A reactor that can power a ship between the planets is a kind of master key. The sun is the source of nearly all our power out in space, through solar panels. But the farther you travel from the sun, the fainter its light grows. Until out past Mars, the sunlight is too weak to be of much use at all. A nuclear reactor does not care how far you are from the sun. It carries its own fire within it. And so a ship like this, could go where sunlight cannot easily reach, out to the cold moons of the giant planets, out to the icy worlds at the rim of the solar system, to places we can barely visit now. To learn to run a reactor between Earth and Mars is to learn the very thing we would need to explore the whole of our solar system. The dark, distant corners that the sun can no longer warm. This small first step toward Mars is, in truth, a first step toward everywhere. And it matters because of what those 3 little helicopters are really doing out there, flying low over the red dust. They are not just scouting a patch of ground. They are scouting our future. They are looking for the place where, someday, perhaps within the lifetime of someone listening tonight, a ship will come down out of the Martian sky carrying living, breathing human beings, the first of our kind ever to stand on the surface of another planet. The flat clearing those drones are searching for may one day hold the first human settlement beyond the Earth. The hidden ice they are hunting for may one day be the water that those first Martians drink, and the fuel that carries them home. These small machines are quietly preparing the way a scout walks ahead of a great caravan, so that when the people finally come, the path will already be known, and the safe ground already found, and the precious water already marked upon the map. And there is a larger reason still, one that reaches all the way down to what it might mean to be human at all. For the whole of our story, every person who has ever lived, every life and every dream, has unfolded on the surface of this single small world. Every birth, every love, every loss, all of it on one fragile blue planet, with all our hopes resting in one single place. To learn to live on another world, to set even a small and struggling settlement upon the red soil of Mars, would be to change that, gently, forever. It would mean that life from Earth, that we ourselves, would no longer have all of our hopes in one basket. It would be the beginning of becoming something new, a people of more than one world. That is a vast and almost overwhelming idea, far too large to truly hold. And yet it begins with something as small and humble as 3 little helicopters looking for a flat clearing and a patch of buried ice. The largest journeys always begin with the smallest, quietest steps. A scout flying low over the dust, a generator wrapped in titanium wings, a first faint footprint, still years and years away, in ground no human foot has ever touched. And now, having traveled all this way together, from the marble distances between the planets to the gentle, endless push of an ion engine, from the roaring engines in the desert long ago to 3 small helicopters waiting in a far red sky. Let us pause for a moment before we begin the slow turning towards sleep, and simply rest in what all of this means. Think of the long shape of it, for all of human history. The planets were untouchable lights in the sky, gods and omens, forever beyond our reach. Then, in a single astonishing century, we learned to leave our own world and to send our machines across the dark to walk on other ground. And now, not content with rare and costly visits, we are reaching for something steadier, an actual road between the worlds, a railroad of patient atomic fire. There is a wonder in that pace, in how fast we have come. And there is a deeper wonder still in the patience it now demands of us. Because this is not a story of speed. It is a story of the slow and steady winning out. A gentle push that never stops, carrying more than any violent shove ever could. A reactor that burns quietly for years on end with no one to tend it. A dream set down for half a century and then patiently taken up again. An old idea, planted in the desert, finally growing. There is a lesson hidden in all of it, soft as a hand on the shoulder, that the greatest things are rarely won in a single dramatic moment, but built slowly, faithfully, over far more time than feels comfortable, by people who may not live to see the harvest, handing the work gently from one set of hands to the next. There is comfort, too, in the smallness of the reactor at the heart of it all. We so often imagine that great things must be huge and loud and overwhelming, but here is the engine that may open the road to Mars. And it is no bigger in its power than the generator that might keep your own lights on through a storm. It does its work quietly, modestly, without drama, splitting its atoms one by one in the freezing dark, asking nothing, making its steady warmth, pushing its gentle push. There is a kind of permission in that. If you let it reach you, you do not have to be enormous to matter. You do not have to roar to move the world. Sometimes the quietest, steadiest, most patient thing is exactly the thing that changes everything. A small, warm engine, glowing faithfully in the dark, carrying its cargo across an unimaginable distance, simply because it does not stop. And there is one more thing worth resting in. Before we let the story go, there is a boldness in this whole plan that is easy to miss. A quiet daring in saying that we will build such a thing now, in this very year, and launch it only 2 years on. It would have been easy and safe and ordinary to call it a project for some distant decade, a someday dream to be handed off to others. Instead, a group of people has chosen to try to do it now, soon, in time for the next open door. They may succeed, and they may not. The timeline is fierce, and space is unforgiving, and a great many things must go right. But there is something hopeful and human in the very attempt, in the decision to reach for a hard thing soon rather than an easy thing never. And whether this first ship flies exactly on time, or stumbles, or has to wait for the door after next, the old dream is awake again now. And that is the thing that truly matters. The road to Mars is being built. The first rails are being laid. And even if you and I only ever watch from here, from the warm, safe ground of our one blue world, there is a quiet joy in simply knowing that somewhere, right now, careful and hopeful people are working to lay a railroad across the dark. That work goes on tonight, even as you rest, gentle and patient and full of hope. And now let us tell the whole story over once more, slowly and softly, the way you might be told a tale as you drift toward sleep, with nothing to hold on to and nothing to remember. just the gentle shape of it carrying you down. It begins with two worlds circling the same sun, the Earth and rusty Mars, drifting near and then far as they go around, so that the door between them opens only once in about every 2 years. It begins with a problem. The heavy and stubborn problem of fuel. The cruel riddle that says you must carry fuel to carry your fuel, until the rocket grows into a great tower that is almost all fuel and almost no cargo. And we find ourselves bumping against the very limit of what we can send across the dark. It begins with engineers asking, quietly, whether there might be a better way. And there was a better way. And it was an old way, dreamed long ago, more than 50 years past, out in the high desert. People built and fired nuclear rocket engines and dreamed of riding atomic fire all the way to Mars. And then the world turned away, and the dream was set down to sleep for half a century, until now. Now the agency has taken it up again and is building, in this very year, a ship called Reactor One, the first vessel ever meant to carry its own nuclear reactor between the planets. Not by burning, for there is no air to burn in space, but by splitting atoms, gently, in a reactor no more powerful than a household generator, and turning that into electricity, and feeding that electricity to soft and patient ion engines that push with the lightness of a breath and never, ever stop. A freight train along an invisible railroad, slow but tireless, carrying more than anything before it, for almost no fuel at all. It begins, this little ship, with the small reactor glowing at its tip, no more powerful than a generator that might warm a single home. Awakened only once it is safely far from the Earth. Behind it sits a cone of shielding, casting a long, safe shadow down the length of the vessel. Behind that, a gentle circle of heat turning quietly into power. Vapor rising and spinning, a turbine, and cooling and falling and rising again. Around and around for years on end with no one to tend it. Then a long, slender spine of metal, holding the dangerous front and the delicate brain a respectful distance apart. Then a great pair of titanium wings, not for flying, but for shedding the unwanted heat softly out into the cold. And then the body of the ship itself, the patient ion engine, born from the bones of an abandoned moon station, gently given a new and grander life, each part simple, each part quiet, each part doing its one small faithful job, out there in the dark, all the way to Mars. And so the little ship is built, much of it from the careful work already done for an abandoned moon station, gently repurposed. Nothing wasted. And when the door to Mars swings open in the year 2028, it sets out, and it falls patiently through the dark for about a year, its reactor glowing at its tip behind a cone of shielding, its great titanium wings shedding heat into the cold, its gentle thrusters whispering it onward. And when it arrives, it lets fall a small capsule named Skyfall, which plunges into the thin red air behind its heat shield and breaks, and blooms a parachute, and reveals at last not a rover, but 3 small helicopters, built from the very design of a brave little flyer that once made 72 flights across that same red sky. And the 3 of them rise up and fly off across the plains of Mars, looking down for a flat, safe place where people might one day land, and looking beneath the ground for hidden ice that might one day be the water they drink and the fuel that carries them home. Scouts, flying ahead of all of us, preparing the way to another world. And behind them, the dream grows toward reactors on the moon that hold back the long lunar night, and toward greater engines still, that may someday carry the first human beings all the way to Mars and keep them safe and warm in the deep dark, far from home. You have come a long way tonight, all the way out to the red planet and back, all the way from the roaring desert of 50 years ago to 3 small helicopters waiting in a far-off sky. And now there is nothing left to do, and nothing left to hold. You can let all of it go now. Let the numbers drift away. The millions of miles, and the watts and the years. You do not need to keep a single one of them. Let the little ship grow soft and dim in your mind. Just a faint, warm glow, far away, falling gently through the dark toward Mars. There is nothing to remember now. There is nothing to figure out. The long journey can carry on without you. You are here, safe and warm and still. Let your body grow heavy and easy. Let your shoulders settle down, away from your ears. Feel the gentle weight of your arms, your hands, your legs, all of it sinking softly into the place where you rest. Let your face go loose and smooth, the small muscles around your eyes and your jaw letting go. One by one, there is no effort left to make. Let your breathing slow on its own, in and out, like a quiet tide moving gently on a far shore, rising and falling, rising and falling, asking nothing of you at all. The day is behind you now. Everything you carried through it, every task, every worry, every small thing left undone, you can set it all down here. None of it needs you tonight. There is nothing you have to solve. Nowhere you have to be. No weight you have to carry into sleep. You are allowed to simply rest. You have done enough. You are exactly where you need to be. Warm and safe and held by the quiet dark. Notice how little you have to do now. You do not have to make sleep come. You only have to let it. Your breath knows the way on its own. Slow and easy, in and out, like that far tide on a distant shore. With every breath out, let yourself sink a little deeper, a little softer, a little farther from the cares of the day. There is nothing left to reach, no distance left to cross, no door left to open. You have already arrived. You are home and warm and safe, and there is nothing left but rest. Far away, in the cold and the dark between the worlds. A small ship is falling gently toward Mars, its reactor glowing soft and steady at its tip, its thrusters whispering their endless patient push, carrying their small cargo faithfully through the night, the way they will keep on doing long after this night is forgotten. And here, much closer, much warmer, you are drifting too, slow and easy, down and down, into a deep and gentle rest. Let the last of the day dissolve. Let your thoughts grow slower and softer and farther apart, like clouds thinning out across a calm evening sky. There is nothing more to do. There is only this quiet and this warmth and the slow tide of your breathing carrying you down. And if your mind wanders, as a mind will, off to some small worry or some leftover thought, that is all right. You do not need to chase it, and you do not need to push it away. Just let it drift on past, the way that little ship drifts on through the dark, and come gently back to your breath, slow and easy, in and out. There is nothing to hold on to tonight. Everything can float. Everything can soften. You are sinking, slowly and safely, into rest, like settling deeper and deeper into still warm water, down and down, with nothing left to carry and nowhere left to go. Somewhere out in the dark, a small warm engine glows and pushes its gentle push and carries its quiet cargo on toward the red planet through the endless night. Rest now, sleep deeply, and let the gentle dark hold you until morning,